there. Welcome to Astraveo's continuing education series, where for our podcast listeners, we talk about mathematics, the physical sciences, of course the natural world, and our personal favourites, astronomy. Now, you know Joseph and I are all up in and about astronomy. We get super excited about that stuff. So let's get going. On today's episode of Astraveo's education series, we're going to be talking about the perimeter and the areas of some simple geometrical shapes. Now, this is very important because it has real value in the world of agriculture, of art, especially science, definitely, even astronomy. But this is the sort of topic that your children will be experiencing in maybe 3rd or 4th grade. They will be, what would they be, 7, 8, possibly 9. And so this is a really important topic, and occasionally it can be a little bit confusing. So we're talking about perimeter and area of various geometrical shapes. Now, the couple of shapes we're going to concentrate on are a square, a rectangle. Remember, a square is just a special form of a rectangle, a triangle, and of course, a circle. Now, we find these shapes very often in everyday life, in nature, and so on, so it's very important. So, let's have a couple of formal definitions. As you know, I always like to start with formal definitions. Perimeter. Well, really, this is the distance around an object. So, for instance, let's take a soccer pitch, a football pitch. My beloved Manchester United, walking around Old Trafford. How would I know what the perimeter of the football pitch at Old Trafford is? Well, if I started at one corner flag, I could, let's do it like this. It is a rectangle. A soccer pitch or a football pitch is typically a rectangle. If I were to start at one corner flag, I would walk all the way along this sideline. I would walk all the way along the back goal line here. Maybe the Stretford end is over here, screaming my name. Walk all the way along the other sideline, and then back behind the visitor's goal there. So that distance, the perimeter, is the distance all the way around the geometrical object, which in this case happens to be a rectangle, a football pitch, or a soccer pitch. So perimeter is the distance all the way around a geometrical object. Well, what about an area? Whoops, almost changed pen. An area. Whoops. An area. Well, this really is how much, whoops, I can't even spell, how much space a shape takes up. Shape takes up. And so really, this is a distance for perimeter all the way around a geometrical shape, the football pitch at Old Trafford. But the area, like how much grass is there, that is really how much space the football pitch is taking up. So really, it's this quantity. What's the size of all that matter or material or grass in there? So the difference between area and perimeter is a little bit subtle. Perimeter is the distance all the way around a geometrical shape. The area is how much space that shape takes up. So a slight difference. And of course, that matters in how we calculate it. So, as usual, let's give ourselves some space. Okay, let's start with a square, very special type of rectangle. Okay, a square. Okay, I'm not the world's best drawer, as you would have figured out by now. Now, the property of a square is that its length is identical to its width. So, in theory, the perimeter is length plus width plus width. But we know a square, these are identical. So let's actually write it out. Perimeter of a square, equals one length. Now, so they're all the same. A square has the same size, the same length sides. So it's one length, two lengths, three lengths, four lengths. So it's actually length times 4. So for the perimeter of a rectangle of length L, don't forget, scientists aren't that super inventive, length is L, The perimeter of a square is just 4 times L. Once you know the length of one side, the perimeter is quite easy to work out. What do you think the area is? So it's a little bit more complicated. You have to actually know this. So the area of a square, to work out how much space it takes up, it's basically one side, one length, times, multiplied this time, by another length. But the lengths are the same in a square. So it's just length times length is length squared, L squared. So for a square, its perimeter is 4 times its length. For the area, it's just length squared. Now they have very different units. You have to be careful. Let's assume we've measured these in meters. I'm just going to use M as a symbol. This would be meters because you're adding up 4 lengths. Here, you're multiplying a length by a length, a meter by a meter. So the units here would be meters squared. You have to be really careful of that. There's a subtlety there. Perimeters are measured in the fundamental measurement unit of whatever your measurement system is. Meters, centimeters, millimeters, miles, kilometers, that kind of thing. The area is the length squared. So meter squared, centimeter squared, miles squared if it's a really big square. Okay, so that's squared. Okay. Oh, sorry, a square, not squared. I apologise. All right, let's go back to Old Trafford in Manchester, in Great Britain. Obviously, the home of Manchester United, my absolute tip-top favourite football team, soccer team. As we rightly pointed out, all soccer pitches, all football pitches, they're rectangles. And so now we have a slightly different way of looking at things. The length of the football pitch, typically about 100 yards, length. Now there are 2 of them. 1, 2. Length. Now the shorter side behind the goals, this we can write as width. Tends to be about 60, 70 yards for a modern football pitch. Width. So now, how do you think we define the perimeter now? 1 side, 2 sides, 3 sides, 4 sides. So I'm not going to change pen color for this, if you don't mind. Okay, this is a rectangle. So my pen didn't work. Perimeter of a rectangle equals 1 side, its length, plus a width, plus the other length on the other side, length, plus the other width. Now, if this is a regular rectangle, like a perfect rectangle, these are all going to be right angles, which means this length and this length are identical, and this width and this width are identical. We have 2 lengths, 1, 2, so it's 2 times L, plus 2 widths, which are identical, 2 times W. So that is the perimeter of a rectangle. Twice the length plus twice the width. And again, let's assume it's meters. These units are meters. They are not meters squared. That's right. It's area that's meters squared. Well done. Glad you remembered that. Now, the area of a rectangle, there you go. I like saying that word. It's a really nice word. Area of a rectangle, if you remember back to the square, it was 1 side's length times the other one. So it's very simple. It's just length times, whoops, squeaky pen syndrome has come back. Length times width. We know with our fancy notation, it's L times W, which in scientific notation is just L, W. And if it were in meters, for instance, it would be meters squared. So I'm going to put the square brackets here to show it's a dimension. The area of a rectangle is 1 length times the other length of the width. However, the perimeter is twice the length plus twice the width. The units here are meters. The units down here are meters squared. Fundamental difference. Okay, so we're in business. What about, Should we do an example or should we move on to a circle? Since we're still here, let's just do a quick example, just so we don't get ourselves all confused. What about, and I'm just going to make this up, okay? I don't know, I'm literally going to make up this. I don't know where I'm going to go with this, but I'm going to do it anyway. There you go, not too bad. So that is a really sort of weird object. It's a bit of a funny size. How are we going to work out the perimeter? Now, I'm going to give you the lengths here. The perimeter is just all the way around. The area is a little bit more of a tricky one. Let's do that first. So let's give ourselves, I'm going to change pen here. Okay, this I'm going to call 10 meters. This one I'm going to call, actually, you know what? I'm going to draw this a little bit better because otherwise things are going to get complicated. Is that right? Yep. So this is, oh, there you go. I told you I wasn't the world's best drawer. Whoops. Okay, so this is right. Now I'm happy. Okay, so this, I don't know, I'm going to say 4 meters. This I'm going to say is 3 meters. Whoops. This, I'm going to give you this because we need it, of course. This is also going to be 4 meters. I like that one. This length I'm going to give as 4, 6. Yep, I like that. Okay, so, oops. This I'm going to give you as 1 meter. And this is obviously 1 meter as well. Oops, and that's 2 meters. Now, I'm not going to give you the other side, the top side. What is the length of that top side? I'm not giving it to you. Well, I did it deliberately. That's why I drew the rectangle like this, or the rectangular part of it. We know this. It's this distance plus this distance. It's 3 plus 4. So actually, we know the length up here is 7 meters. Now, this is typical. You'll see this on a standardized test for an 8, 9, maybe probably a 10-year-old here in the United States, probably a year 4, year 5 in Western Europe. And I'm not sure how the years go in Asia or Africa and South America. I used to live in South America, but I can't remember how it goes. But typically, this would be about maybe a 9 or 10-year-old's question in school. Well, the perimeter is easy. We just start here, say, and we add up the distances all the way around the figure. Well, we can do that. So let's do perimeter. We just add them up. Let's start here and go clockwise. Well, this is 10 meters. 10 meters. Plus, let's walk along here. That gives you 7 meters. Let's walk down here. That gives you 2 meters. Let's walk along here. That gives you 1 meter. Let's walk down here. That gives you 2 meters. Let's walk along here. That gives you 1 more meter. Let's walk down here. That gives you 2 meters. We're going to walk along this length here, which is 3 meters. We're going to walk down to the bottom, which is 4 meters. And then finally, back to where we started, another 4 meters. Okay, I think we got that right. Let's just make sure. 10 meters, 7 meters, 2 meters, 1 meter, 2 meter, 1 meter, 2 meter, 3 meter, 4 meter, 4 meters. Great. Okay, one thing that may have confused us a little bit, that's 1 meter, is that's 2 meters. Okay, so now we just have to add it up. 10 plus 7 is 17, plus 2 is 19, plus 1 is 20, plus 2 is 22, plus 1 is 23, plus 2 is 25, plus 3 is 28, plus 4 is 32, plus 4 is 36. So, 36 meters. The perimeter of this object, which originally we thought may be a bit complicated, is 36 meters. Not too bad at all. Right, let's do the area. Now, the area we have to be a little bit careful of. So the area, that's quite a tough one to work out the area, but we can help ourselves. It's not actually that difficult, and I'll show you why it isn't. This is basically a big shape. It sort of could be this, look like somebody's apartment maybe, but it's made up of geometrical shapes. So what we can do, and I'm going to use my red pen. Actually, you know what? I'm going to change colors here because I've already used red. I'm going to split this up into different shapes. If I do dotted line, this is 4 meters by 4 meters. This is a square, and we're going to call it A. Well, I'm going to chop off here. We have a rectangle, 1 meter by 2 meters. I'm going to call this B. And then here we have 7 meters by 2, 2, and 2. So this is a rectangle, and we're going to call that C. So really, the area of the whole thing, the area of the shape, is just the area of A plus B plus C. A plus B plus C. So area equals. Now A is a square, 4 meters by 4 meters. So 4 times 4. Plus B is this tiny little rectangle, 2 meters long, 1 meter wide. The area is just length times width. So it is 2 times 1. And then finally, C, this big thing, is 3 meters plus 4 meters. This is 7. And this is 2, 2, and 2. So it's 7 times 6 meters. This is all meters, by the way. Meter squared, sorry, it's an area. 4 by 4, 4 times 4 is 16. Plus 2 times 1 is 2. Plus 7 times 6, if you remember your 7 or 6 times table, 7 times 6 is 42. So it's 42. So we have 42 plus 16. 42 plus 10 is 52. Plus 6 is 58. Plus 2 is 60 meters squared. Don't forget the units, meters squared. So we were able to work out the perimeter by adding up all the lengths all the way around this quite complicated shape. Now the area we thought was actually very difficult, but we simplified things by chopping it up into pieces. This room could be, say, the bedroom. This could be the lounge plus the kitchen, and the B could be the bathroom, for instance, if you lived in an apartment. So what was really a difficult question to figure out the area, we made much more simple by chopping it up into smaller geometrical shapes. We knew this was A was a square of 4 meters by 4 meters. We knew B was a rectangle of 2 meters by 1 meter. And we knew C was a rectangle of 7 meters by 2, 2, 2, 6 meters. There is C. And then once we chopped it up, we only have to then add up the areas of the individual components to give us our final answer. And so really, when you're confronted with these types of problems, even though it looks difficult, you just have to remember your fundamentals. Perimeter is the distance all the way around the shape. An area, even if it's complicated, turn it into simple shapes that you know. Rectangles and squares are a great way to go if you can. Let's visit triangles and circles on another episode. Thank you for watching.